So there's all sorts of switches. This is a switch. This is for your ground wire. What that does is that protects, there's continuity between here and here and here and here. This protects the body of the switch. This is what you call your equipment ground. If any of these wires inside here touch the shell, this will make it grounded, which means that instead of when you touch this, you will not get shocked. This will hopefully cause the breaker to trip. Your hot wires go here, okay? One side is a wire feeding in and one side is a wire feeding out. This is not your common outlet, it's a duplex, but it has this line going out. It allows you to use it for 15 or 20 amps. 15 amps is the most common, which would be two straight lines. The side line, or the side part of the T, is allow you for a 20 amp plug. The electrical code says that all 20 amps have to look a certain way, all 15 amps have to look a certain way, all 30 amps, and so forth. They're helping protect you so you don't use the wrong device at the wrong voltage. This is the where the neutral wire goes. It has these two adjoining because you have one outlet here and one outlet here, and it's allowing one wire to work for the top and the bottom duplex. Here is where your hot wire goes, and it's the same. These plugs no longer act as one plug, they act as two plugs. They break this so that you'll have one bottom is switched by a light switch, maybe say here on a wall, and the other one is hot all the time. So they break it so you can have two different feeds on these outlets. Once again, this is a duplex 20 amp plug. It can also be a 15, and that's how you do it. The code talks about this screw has to be a 632. You cannot use drywall screws. It has to be threaded. Everything is a certain size and a certain rating. Over here we have other duplex outlets, but they can come square. Sometimes for a clock on a wall you'll see just a single, but this is pretty common except for the fact that this is 20 amps for your home. Okay? Once again, your ground wire will go on the green or bare screw, which protects the equipment. Grounding, how you realize grounding in the code, grounding has two G's, G-R-O-U-N-D-I-N-G, grounding. Grounding is either the green wire or the bare wire in electrical. Green wire or the bare copper wire, okay? They do, in some systems in the 70s, they experimented with some aluminum wiring. And aluminum wiring they found to get hot and actually cause fires. So they don't have that so much in houses anymore. And they actually have to put a certain kind of grease on there, electrical grease, to help keep it when you put a copper wire to aluminum wire, because two different dissimilar metals will eat each other. And they will create corrosion, which will create heat. And the heat is also a resistance to current flow. The more resistance, the more heat, and it kind of builds up and it can cause a fire. But once again, this is 15 amp, 120, 277, which is pretty common for your outlets, switches, and so forth. If you look on this one, there's a black part on this flashlight battery. That's an insulator. That does not allow flow. This little tit part here, the silver part, goes to one edge of the filament, and then the other one goes to the shell. So basically on any light bulb, if you take a meter on continuity, which checks flow, and you go ahead, and I'm going to use my stomach here, and I touch the tit and the shell, I have continuity. And I also have 1 ohms of resistance. That means that this will shine. This will work. Many devices do not have a grounding wire. This has 2 wires, typically in and out, or a hot and a negative. This one here, I don't know what this is rated because a nameplate, which was cheap, came off of it. But this is a siren for my alarm. Yes, I got lots of alarms at my house. You come to my house and I got alarms, booby traps, I got everything. So don't come to my house. But this is a speaker alarm. So it may not sound on this because the average alarm is like 24 volts. We have this battery here, and this battery says that it's a C battery, so it may make a little noise. So I'm going to the negative and to the positive. And you can barely hear it. Really barely. But You can also put voltage batteries in series. And I'm going to go tape one up and come right back. And you should be able to hear it because we'll do twice the voltage. And I'll get you bigger batteries with more voltage. Voltage is pressure. Your car battery is 12 volts typically, unless you have a Volkswagen, which is 6. But you have a hot and a negative on your batteries. I'll be right back. Just because something works at your house doesn't mean that it's going to work right. There was a heater. A heater basically has a wire that goes up and down for resistance. This heater was a 120 heater, and a handyman hooked it up to 240 volts. He did not ground the metal of the heater. A small 5-year-old girl touched it, and it went ahead and it had become 240 volts, and it shocked her and it killed her. So just because it works doesn't mean it's safe. Before we had a C battery, and we could barely hear this, this probably works off of 24 volts. So I'm going to put this on the negative and put this on the positive. Once again, I can barely hear it. Now I'm going to double my voltage by putting these together. And I'm going to try to hold this. It works much better because I doubled the voltage. This is called series. When you put plus to negative, it's called series. These batteries are in series. Okay? This is part of basic electrical. You heard my siren. My real home siren is about 20 times this loud. So for you burglars, watch out. What we need for a circuit is we need a power source, be it an electrical panel with 120, 240, or we could do a car battery with a plus and a negative, which is 12 volts, or we can do a regular battery. We can do a 9-volt battery. This is our power source. Then what we would have is we can have a load, which is just a light bulb. And it comes over here off of 2 wires. Okay? So now we have a circuit. We have our power source, we have a load, we have a circuit. And so that it doesn't go dead, we can have a switch in between. Okay? And then in our homes, the only difference in our homes, what we have is we have right here, before the switch, if this were plus and this were negative, we have a device right here, which is a breaker. And I'm going to redraw that again really quick for you. We're going to talk about a breaker, and we're going to talk about protection of our system. What we have is you have the hot wire. You have a switch, maybe to turn it on and off. And then you have, what do you guys like, television? I know, you guys, couch potato, okay? Couch potato has its television set. Old days they had bunny ears. Okay, that's your television set. And then it'll go back to neutral. Well, do you want that $500 or $400 or $2,000 TV set to go ahead and trip? Basically, it has like a load, which we'll just draw as a resistor. That's a resistor. That's your TV set. Right here, they put a breaker before the power source. This thing here protects this wire, protects this switch, protects this device, and it protects you for ground fault and overcurrent. Overcurrent means too many amps. Okay? So that's what a breaker does. A breaker's a safety device. A fuse is a safety device. This is your ground, the very bottom, and then you have 2 slits. Your ground, your smaller one is your hot, your bigger one is return. Old plugs, they weren't, the holes were the same. It was called non-polarized. Now it's polarized, meaning everything, they're trying to make exactly what it's for. Only certain items will fit in a certain size. Whatever's rated for one will be rated for the other. So basically you could put a cord like this. You do not want to use this for house wiring. Here's why. See how small these wires are here? This is what's inside. Our green is for our equipment ground, our white is our return, and then our black. Now if we wanted to know about return of amps, here's something we could do. We could take my microwave up here, and unplug the microwave. This is a surge protector. They're really great for anything that's expensive in your house, like a TV, a fridge, a microwave. It's really nice. You get these surge protections. This is a fixed microwave that I had to plug in, so if I put this here and then I plug it in here, basically the microwave has to go through this cord. And I was taught as a kid to never put anything in the microwave without, I got some water in here, so I'm going to put water and a glass in the microwave, and now I'm going to turn it on. Now remember, this meter has this little thing that goes like this, and that's for amps, okay? Oh, I got my cowboy hat on because I'm trying to show you my countryside, like you really care, right? Anyhow, this has a horseshoe for resistance, V for volts. This is a digital meter, and it also has V for amps, or A for amps. So what I'm going to do now is first I'm going to turn my voltage meter on to make sure that it has power, which it does, because these don't work without a 9-volt battery being inside. Now I'm going to turn it to amps. Now I'm going to turn my microwave on. But before I do, I'm going to show you, I'm going to put my little meter here, and I'm going to show you on the hot wire, I'm reading how many amps, or the rate of flow going through. 5.7. 14, now it's 14 amps. Microwaves pull a lot of power. This is 14 amps. I shut this off. Now, I'm wondering if I'm going to have voltage on this side. Now I'm on the return wire, and I'm going to see if I still have my 14 amps when I turn it on. Sure enough, on the white wire going back, I have basically almost 13.3 amps. So it's telling me virtually almost everything going out is coming back. Now if I go to the hot again, the hot is 13.9, and the white 13.5, 13.2. It's digital, so it fluctuates a little bit. Now it's at 14.4. I go to the white. The white's at about 13.8, 13.5. So what it basically tells you is what's coming out should be basically, for the most part, coming back. Okay? And how a GFCI works in your house is it measures within 0.006 of an amp difference. Electronic equipment sometimes holds a little bit of energy before it returns it. Typically they work, it should be reading almost exactly the same, but this is digital, so it's fluctuating, 3 or 4 tenths of a volt, roughly. Okay? But that tells you that we have amps going up, amps going down, and once again, this is just the extension cord. You don't want to use these as permanent in your house because these are much less than your house wiring. Your house wiring is like normally 14 gauge for a switch or 12 gauge. The smaller the wire number, the bigger the wire. This is like 22 or 18, so the bigger the number, the smaller it is. Once again, small wires have big numbers, big wires have small numbers. So this tells you a little bit about amps. I hope you understand it. I hope you don't have extension cords at your house. They are a huge fire hazard. So if you have too many extension cords that replace your natural wiring, look and see where they are. Heaters, you should not have heaters with extension cords. You should not have any appliance that draws a lot of amps, anything more than a few amps. Or if you have a whole bunch of little amps, it can add up on this cord, heat it up, and it will go ahead and catch on fire before your breaker trips, or before your breaker even registers the heat. Okay? That's another quick tip by your friendly Western electrician.